Hello. So yesterday you did a little bit of summary for some of those terms. One of those terms was the Doppler effect in terms of cosmology, or like Hubble's constant, the red and blue shifted. Right, so I just wanted to kind of go through that and clear that up a little bit today before we move on. So I talked yesterday about the Doppler effect. So like if you have an ambulance, okay, so that's an ambulance, and this is you. Okay, if that ambulance is headed towards you, the sound waves from this ambulance, okay, is going to get kind of bunched up. Like it's like a slinky. Like obviously if this person's still and I'm pushing the slinky towards it, all those coils in the slinky is going to get started to bunch up. Okay, and then as the ambulance heads away from you, it's just like stretching the slinky. Okay, it's actually going to get more elongated. Okay, the same thing applies, and these are sound waves, but the same thing applies to light, because light is waves. It travels in forms of waves. Okay, so if we have a star, and that star is moving towards us, the light from that star will get compressed, and we call that a blue shift. And the same thing applies the other way. If the star is heading away from us, it gets stretched, and that is our red shift. Okay? So what that means is the reason why it's colors rather than just sound is because we're dealing with light, and light travels just like sound travels at different frequencies. The more energetic the frequency, the more blue shifted it gets. Okay, blue is like the highest frequency there is. Red is a very low frequency, and then you have pretty much everything in between. Okay, so basically if Hubble actually figured out that the velocity of the stars, so how fast they're actually moving, okay, so they do have a velocity. What Hubble figured out was that the velocity is proportional to the change in frequency. Okay, so what the change in frequency is if it was standing still, like if it wasn't moving, what would the normal frequency be? And then he would look at what the average frequency would be for a still object. Then he would look and see if it's crunched up, if it has a higher frequency, how much higher, or if it's more stretched out, has a lower frequency, how much lower. Okay, and obviously if the more redshifted it is, it means the lower the frequency, it means it's moving away faster. Versus a blue shift, the higher the blue shift means the higher the velocity towards the person. Okay, so that was kind of Hubble's law right there for red and blue shifted. Okay, so that's pretty much it for today. I just wanted to clear that up, and before we move on, so we were looking at, yesterday we kind of looked at the start of like the Big Bang, where the idea came from, and we're going to look at, so this is what Hubble discovered, and so we're going to continue with this and look at how this actually applies to helping us find the age, or what we estimate the age of the universe to be. Okay, we'll do that tomorrow. Alright, thanks guys, have a good day.